In how many tries do you think programmers get their code run perfectly in C language? The correct answer is almost never. Hi everyone, I'm Resa Adhikari, a junior majoring in computer science and minoring in mathematics. Being a computer science student, I'm interested in coding and C is one of my best languages. However, C is not one of the easiest languages to learn and work on, so it is not everyone's cup of tea. Therefore, I'm working on repair tools and techniques that can automatically fix bugs in the C code. I'm currently working under guidance of Dr. Alison Sullivan for this project. So programmers spend usually more time debugging than writing the code. Because of this reason, there are several IDEs and debuggers built so that the users can easily eradicate the slightest errors in their code. Though the IDEs and debuggers provide good help, bug fixing still takes a lot of time and effort. To bring an end to this problem, some of the software developers have tried to design a perfect repair tool that can determine the error and solve them on their own. Till now, there are more than a dozen repair tools created, and engineers have not successfully found the one. So, why are there so many repair tools, and why do they not have good efficiency? Also, which repair technique works best, and can engineers ever develop a perfect repair technique that can solve all the errors in any given problem? Um, so for this research, my first step was to download Code Plus benchmark, which consists of over 3,900 faulty C codes. Then I had the plan of running the faulty codes on repair tool benchmark like either Angelix or the GenProg, which I finally got installed on my laptop after a lot of hassle. I found the code flaws along with other repair tools were not updated for a long period of time, and trying to figure out how to get everything started was a lot of hassle. My mentor had to email some of the creators of Angelix and GenProg, I believe, because the instructions were not clear on the website. Even getting these tools to work was impossible, so I opened and looked at the codes in the CodeFirst benchmark and tried to understand them on my own. When I looked at the code, I realized that the codes were very short and there were very small portions of the code which do not represent real-world programming. In real-world programming, the codes are way lengthy and they are way more complicated to understand. Since trying to get the tools running was very challenging, I tried to create an empirical study with the research papers that I found online. I came across a lot of research papers and then realized that there are more than a dozen repair tools created till date, but but the major ones were Angelix, GenProg, AllRepair, SPR, and DeepFix. These tools have their own mechanisms to correct the faulty codes, and they do not work on. They do not have same efficiency, and they have different mechanisms. So they do not solve the errors in the same way. GenProg and SPR would mutate the code and delete or add a patch for the code to remove the error, which can remove other functionalities of the code as well. This decreases the efficiency of the code. When I looked through all the papers and tried to compare the repair tools with each other, I realized that the tool with the most promising results was found to be Angelix, which is a semantic-based repair tool. Though it is only available in Linux till now, it can fix bugs in the front end, inference, and synthesis. Also, it is more scalable than other semantic-based repair methods like itself, which are semi-fix and DeepFix. To give a life to the empirical study, I'm planning to work with my mentor, Dr. Sullivan, in the summer and try to run the repair tools physically on my laptop. Then I will have a greater understanding of the repair tools, and then we can decide which repair tool which repair technique is best, and then create a tool that can give close to perfect results. I would like to thank Dr. Sullivan for supporting me through this research project, and I would also like to thank Office of Undergraduate Research for providing me with the opportunity, which will help me a lot in future endeavors. Thank you, everyone.